So Edexcel, June 2018, A-Level Maths, question 1 from paper 2. So it says here that g of x is 2x plus 5 over x minus 3, where the domain is x greater than or equal to 5. Find g of 5. Well, let's first of all find g of 5. So g of 5 equals 2 lots of 5 plus 5 over 5 minus 3, which we're just going to type in the calculator. So 2 lots of 5, make sure I put a fraction there as well, so 2 lots of 5 plus 5 over 5 minus 3 equals 15 over 2. So that's g applied once, let's apply g again. So then g of 15 over 2 equals 2 lots, 15 over 2 plus 5 over 15 over 2 minus 3 equals, so 2 lots, and let's change that to 15 over 2 now. So 15 over 2, and then 15 over 2, there we go, equals 40 over 9, so that's the answer. G of 5 equals 40 over 9. So there's our answer, the first part. So part B, state the range of g. So part B, state the range of g. Okay. So first of all, we need to find out what the value is at the boundary. So I see here that x is greater than or equal to 5. So let's sub 5 in. Well, we know from previous part that g of 5 equals simply 15 over 2. Now let's have a look at the other side. It starts at 5. We can start some values in from x equals 5. So actually now we want to see how high we can go. So let x tend to infinity. The right hand side is unbounded. So as x approaches infinity, that means that 2x plus 5 over x minus 3, i.e. g of x, approaches. So what we've got to think about is these terms become insignificant. As x gets bigger and bigger, it's the x's that matter, and this plus 5 and minus 3, they're going to get completely overshadowed by the x's. So it approaches 2x over x, which is equal to 2. So as x approaches infinity, the function itself approaches 2. So we've got our two limits there. Therefore, so it can be anywhere between 2 and 15 over 2. So 2 is less than f of x, or actually it was g of x, wasn't it? We'll call the function g, not f. So less than g of x, less than or equal to 15 over 2. Now it's important that we have this strict inequality here that says less than, because as x approaches infinity, we'll never actually get to 2. It's an asymptote, but we'll get closer and closer and closer, much like we'll never reach infinity. So because we can't reach infinity, we can't reach 2. However, we subbed 5 in to get 15 over 2, so it can equal 15 over 2. Right, so next part, find inverse g of x, stating its domain. So part C, so we've got g of x was 2x plus 5 over x minus 3. So what I like to do to find the inverse, I write first of all y equals 2x plus 5 over x minus 3. Therefore, inverse is, an inverse is just swapping the x and y values. So the inverse is x equals 2y plus 5 over y minus 3. But that's not yet an acceptable form. We need to rearrange that to say y equals, and in turn write inverse g of x equals. So that implies that x, y minus 3 equals 2y plus 5. Which implies that if we multiply out that bracket, xy minus 3x equals 2y plus 5. And then let's get all the y's on the left hand side and everything else on the other side. So that in turn implies that xy, take 2y, equals 5 plus 3x, which then implies, let's take out a factor of y, so y x minus 2 equals 5 plus 3x. Then we've finally got y equals 5 plus 3x over x minus 2, and conclude properly in function notation. So inverse g of x equals 5 plus 3x over x minus 2. But no definition of a function is complete without giving its domain. When we know the domain of this function, because we've just swapped the x and y values, the domain of the inverse is the same as the range of the original function. So let's just copy out that range and make a slight modification to it. So 2 less than g of x less than or equal to 15 over 2. And hopefully you're shouting at the screen now saying that's wrong, because we don't give domains in terms of g of x. The domain should just be x. So we'll copy out the range for the original function, but what we do, we eliminate any trace of the function notation itself, because the domain refers to x values. So 2 less than x less than or equal to 15 over 2, and that's question 1 done.
For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.